You must have received my post in MA101, general, where I told you about a mistake that I committed in my lecture 9 video. Okay, so I made a blunder over there. You will see what it was. See, when we were talking about finding the partial derivative of a function of two variables, when we find, say, suppose this is my given function, okay, when we find, the partial derivative of this function with respect to x, so what we are going to do, we are going to keep y, or we are going to consider y, the variable y as a constant, because I am partially differentiating it with respect to x, right? So in that case, this is going to result me this function, it is going to be 4x cubed y cubed, okay? And here, again, since I am considering y as a constant, so you know that this is going to be your cos xy. Again, since y is constant, if I differentiate xy with respect to x, so that is going to give me y cos y, right? So likewise, if I find out partial derivative of this function with respect to y, so this part is going to give me 3x to the power 4 y squared, and again this part, now because your x is constant, so this is going to give me x cos xy, okay? So now the blunder that I have made is while trying to again find partial derivative of this with respect to y and partial derivative of this with respect to x, okay? So now let us partially differentiate this with respect to y. So then for this, I am going to write it as fxy xy. So then you will see that the first function, now I am keeping x as constant because I am partially differentiating this with respect to y. So this is going to give me what? This is going to give me 12x cubed your y squared. Now I made the mistake in this function. Okay, so if you look at this, now because I am differentiating with respect to y, you can see that this is a function. This is a function where I have this as a product of two functions. One is y, and the other one is cos of xy. So if I apply product rule, so this is going to give me plus cos xy, and again further what it is going to give me? It is going to give me minus again sin xy, and if I differentiate xy with respect to y, it is going to give me x. So eventually this is xy sin xy, okay? So likewise for this function also, now because I am going to differentiate this with respect to x, so then what is going to happen for this one? Again I am going to have, so this one I am going to have your 12x cubed y squared, and again if you look at this, once I differentiate this with respect to your x, again this is the product of two functions of x into cos of xy. So the first term, it is going to give me cos of xy, and again the second term, if I differentiate xy with respect to x, it is going to give me y. So eventually this is going to give me xy sin xy, okay? So now hopefully you have got where I made the mistake, and I once again thank Kunal Pal for pointing this out, okay? And I'm going to post this in your post this as a video as an appendix, okay? And again here you can see that for this particular function, your f of xy has become f of yx, and if you have seen Clairaut's theorem, you can see that the original function, it satisfies the conditions for Clairaut's theorem. So that is why I get these partial derivatives as equal. Okay, thank you.